So hello everyone. In the last videos we studied first of all that du equals dq plus dw, where dw was nothing but minus times of pdv, and this was our first law of thermodynamics, and where we saw that internal energy is nothing but heat content of the system and work done by the system. And in the second video, we studied why this work is minus times of PdV. We studied about the reference and why work done is minus and work done on the system is positive. So we studied that in the second video. If you are confused, you can just watch it. Now, we are going to study something different from these equations. We are going more basic. So actually, these dq, du, dw are actually differential form of equation. So these are not the exact equation. These are the equations written between some state points. Let's say a process is going between point 1 to point 2. So there will be some change in energy which will be written as du. There will be some heat transfer which is written as dq, and there will be some work done which will be written as dw. But what is the condition at any one state? So there the equation is then changed into U equals to H minus PV. So this is the main equation, and when we differentiate it, that is, if we want to write it between 2 points, so we'll write delta U, delta H and PdV. So this is the main equation. We have to remember this, and we have to remember that from this only we got the first law of thermodynamics. So these are essentially the same equation. Now we know that U is H minus PV, or du is dq minus pdv. Okay, so for time being, let's assume that dh is dq, and I'll prove this. So for timing, let's assume this. Now we know that internal energy of a system is dependent on temperature of the system and volume of the system. So we can write u equals to u t comma v, and there are actually three parameters t, v and p, where u depends on these three, but taking 2 is sufficient enough. P is function of t and v itself, so this is enough. And then du we can write it as del u by del t at constant volume dt plus del u by del v at constant temperature dv. Now let's take a condition. Let's take v to be constant. So our du will then become, this term will become 0 because dv is 0. So du will become del u by del t at constant volume dt, and this du is nothing but dq minus pdv, and well, dv is 0 because v is constant, so we can just remove this part. So what we got is del u by del t at constant volume times dt is dq, or we can say this term is nothing but cv, heat capacity at constant volume. So du is nothing but cv dt. So this is the second equation which we have got from this. Condition is at constant volume.